Okay, so today we're going to be looking at mass movements. We'll be looking at 231, which is weathering and accumulation of debris on slopes. So just follow along. Move this around a little bit in case you need to see me. All right. So when we look at this, I think I talked about this a little bit. I talked about it being landslides. And oftentimes that's what we think about when we think about mass movement and movement of land. There are many different types. Landslides are the most obvious one, really quick movement of land, but there are different types, and they're all important to management of the land in terms of protecting humans, protecting animals, protecting native species and things like that that make the earth thrive. They can be devastating, sometimes preventable, where human tragedy is concerned. So we're going to be looking at the processes behind them and how to manage them. So we already talked about rock weathering being the breakdown of rock in place, all right? So weathering is a process which acts on the Earth's surface to decompose and break down rocks. Two types of weathering we're mainly concerned with. Oh, and I'm sorry, the information, if you look at this site right here, this is where a lot of this information comes from. But again, I've consolidated it on our site here. The two types of weathering we're concerned with here are mechanical, which is like physical weathering. That's going to be any kind of breakdown that happens that just like breaks it into smaller pieces. You don't change the structure of it, you break it into smaller pieces, whereas chemical weathering is the actual changing of that rock, like dissolving, putting it into a different form in terms of its chemical structure. So mechanical weathering, breaking down rock from bigger to smaller pieces. Four basic types we've got here. We've got expansion and contraction. So that's where basically you have temperature change. The temperature change, the heating, the cooling, that can break the rock down, causing expansion and contraction of the rock. Frost action, you can see right here. It's called frost wedging, all right, or frost action. It's basically where you have a crack in the rock, right, and then it will fill with water. And just like if you have ice in your freezer at home, if you put ice in the tray, not the actual maker, but if you put it in a tray, if you fill it up to the top, it will like expand out and basically take up more room. And that's because the molecules in water, what happens is when they are flowing around each other in liquid form, they kind of go right around each other. But then the really cool thing happens with water. It doesn't happen with every solid, but with water, when it solidifies, it forms a crystalline structure, which then has space in between those atoms, those molecules, and that actually takes up more space. So when water freezes, it takes up more space. So if water gets into this rock and then it gets cold and then it freezes, it'll expand and actually break the rock apart. And this can happen in cold areas. All right. Exfoliation is the process in which curved plates of rock are stripped from a larger rock mass as it comes off. And there's other types that can be cracked by plant roots, burrowing animals. We could call this biological weathering as well. Chemical weathering is the breakdown of rocks by chemical processes or reactions. Like I said, it actually changes the structure of the rock. The main agent for this is water. So water will carry rocks, but also have acids in it and different type of dissolved chemicals that react with the rocks and deteriorate them. The major acid that's responsible for this is carbonic acid. And that's produced when carbon dioxide from the air dissolves in water. There's naturally occurring carbon dioxide in the air, dissolves in the water, makes carbonic acid, and can break down the rocks. We're going to talk about that later in terms of ocean acidification, where this does happen in the ocean as we increase our CO2 levels. Not only does the planet warm, but actually the pH of the ocean goes down, and that's contributed to coral bleaching. But in this case, we're just talking about the breakdown of rocks. So the factors that affect the rate of chemical weathering are particle size. The smaller the particle size, basically you have the greater the surface area. Think about a sugar cube, right? You have a sugar cube, the only surfaces that touch anything it's trying to dissolve in are the 6 sides. But if you break that down and crush it, it's going to dissolve faster. Same thing here. And that's because more of the inside is now out. That's called surface area. So the more you break these things down, the more surface there is to touch the acid to break it down. Smaller rocks will dissolve faster. The composition, different things dissolve differently, react differently, so the composition can matter. The climate, we're going to talk about that in a second, right here. All right, so you've got the climate, and climate basically breaks down. We're talking about this much later too, a lot. We're going to talk about this a lot. Rainfall and temperature are really contributing to climate. So the less rainfall with hot temperatures, hot's down on the bottom here, is not going to have a lot of weathering. However, if you have a lot of rainfall and hot, you get strong chemical weathering because hot and water give you more chemical reactions. However, cold, all right, and not a lot of, or cold here, and not a lot of rainfall is going to give you mechanical weathering. Your strongest mechanical weathering is going to be where you have pretty cold and medium rainfall, because that's going to give you a lot of that frost action there. And so you can see the different climates that can give you the different types of chemical weathering. And finally, the last thing that could happen there is the type and amount of vegetation. So you can read about that there. Accumulation of debris on slopes. So mechanical and chemical weathering can both result, when it breaks down, in the accumulation of debris or smaller rocks that just start to accumulate on a slope. Eventually something could happen. I'm sorry, the term for these piles, the rock is broken down and then will roll down the slope. The terms for that rock are called talus or scree. You might hear it as both. The accumulated rock are sometimes called talus piles or scree slopes. Because the mass is greater, larger rocks will have momentum due to gravity and fall down towards the bottom of the slope, while smaller fragments may stop. So the larger ones will have that momentum and just keep rolling down. And this usually happens on slopes. And what can happen to cause this? Any kind of shaking of the ground. An animal may push it down. It does. I mean, any kind of movement is going to cause these things to roll, and they become rock slides, and that's not cool. Rocks sitting on a slope, large or small, may become unstable and fall to the bottom. Also, it could happen because of increased lubrication from rain, increased weathering and erosion, or frost melting, forcing a water flow down the slope. So usually, I mean, it can happen because of shaking, it can happen because of water movement. And that's pretty much it for this section.